Hi guys, so today we're going to be looking at Chapter 5, Section 2, Properties of Rational Exponents and Radicals. And this is going to be Part 2. So we're going to start off first with adding and subtracting like radicals and roots. For example, let's try out this problem right here. We're asked to simplify the following expression. So if we have the same index and the same radicand in the inside, then what we can do is we can combine the outside coefficients. So over here, if you don't see that there is like a coefficient on the outside, you can always write down an imaginary one first. And so we get here 1 for root 10 plus 7. Then right here is another 4 root 10. And again, we can just combine our coefficients here. So 7 plus 1, that just gives us 8. So I get 8 for root 10 as my final answer. Done. For exponents, it's still the same thing. You just need to make sure your base is exactly the same, your exponent is exactly the same, and if both are the same, then you can combine the coefficients again. So 2 plus 10, that gives you 12, and we're left with 12, parentheses 8, 1 over 5, and closing the parentheses. And there's nothing else you could really do. Okay, so that would be our final answer. In the case that we have here, 3 cubic root of 54 minus the cubic root of 2. As you can see in the inside, they're not the same. But I do know that I could probably simplify my radical. And the best thing to do is always to try and simplify it to see if there's anything that you can take out of your radical. So, if you don't know what you can take out, you can always use the factor tree to help you out. So you can use 6 times 9. 9 can be 3 times 3. 6 can go into 2 times 3. So I do know that my prime numbers here are 2, 3, 3, and 3. And seeing over here, as I'm supposed to be taking out groups of 3, I know that I could take out a group of 3's right here from my cubic root. So I would get left with 3 cubic root of 2, which is what we wanted. We wanted the 2 on the inside. And so I can combine it again. And just a reminder, if there's nothing, no coefficient on the outside, you can always write an imaginary 1 here. So I get 3 minus 1, that equals 2. So I get left with 2 cubic root of 2. Okay. Next one, over here on the other side, again, I still want to simplify as much as possible. So I'm going to simplify the inside of this cubic root. I see that we have 5 z's. And I could probably take out one group of z's, since we have here z times z times z times z times z. I could take out a group of z's, and my leftover would be those 2 z's. So on the outside I have 12z cubic root of 2z to the power of 2. On the other side, we already know the cubic root and how we can simplify out a 3 from 54 because we already did it over here. So I'll take out a 3 and I'll be left with 2z to the power of 2 on the inside. And then from here, again, I'll just switch it around so that makes it nicer to see. Okay, So we have the same radicands, and so I can combine the coefficients together. And also it has to be the radicands and also our z to the power of 3. That needs to be exactly the same. So since all three are exactly the same, then I can combine it as 12 minus 3, which would just equal to 9z to the power 3, or sorry, z cubic 2z to the power 2 is our final answer. Done. Okay. All right. So, simplifying variable expressions. Before we even get into the question, here's a rule that we're going to be looking at. If we have the same index as the exponent inside of our radical sign, we want to identify what happens when our n is even first. So, for example, let's say that you have here 4 root 3 to the power of 4 versus 4 root negative 3 to the power of 4. So we want to see what happens to our answer first. So I'll just solve this out. I'll start off by solving out the inside. 3 to the power of 4, that equals to 81. And I know that this would be, 4 root 81 is just 3 in the end. Over here on the other side, if I were to do this, negative 3 to the power of 4, that would still give us a positive 81. And so we would actually get the same answer. So if our n, or our index and our exponent, are both even, then we can say that our answer will always be positive. So our answer will stay positive. And since it will stay positive, then we're going to have the rule where if you have the case where your n is even and you have the same index as your exponent on the inside, then this is going to equal to the absolute value of x. Because no matter what, whatever your x value was, which is, for example, over here our 3 or our negative 3, our answer is always going to end up to be positive. And so we always have to make sure to write down the absolute value of x in like any case where maybe we're not given numbers, we're just given variables. So this helps us make sure that our answer stays positive in the end. Now, what happens if n is odd? If n is odd, let's try it out. So let's say that your n is, or your index is 3, which also means that your exponent in the inside is 3. So if I were to solve this, I get here cubic root of positive 27, and this equals to positive 3. Now in this case, where we have a negative x value, if I were to solve this in the inside, I get negative 27, and the cubic root of negative 27 is negative 3. So in this case, our answer doesn't stay positive. Our answer instead stays whatever our sign was originally. So in this case, our answer is always x in the end. Whatever our x value was is our answer. In this case, our x value is going to be the same too. So when our n is odd, then we just get x as our answer. So this only happens over here, the absolute value only happens when it's even. This one only happens when n is odd. So if that helps you out, then let's try out this example here. We have here 4 root x to the power of 4 divided by y to the power of 8. Before I do anything, I'm going to split up my root from the fraction so that we have 4 root x to the power of 4 over, this will be 4 root y to the power of 8. So from here, if I were to solve this, again, 4 is an even number and it's the same as the exponent inside. So when I solve this, I'm going to get absolute value of x on the inside. Now, the easiest way to solve 4 root y to the power of 8 is to always rewrite it into the fraction format. So my fraction format is y 8 to the power, y to the power of 8 over 4. And the reason why I want to do that is because now I can simplify this as a fraction instead of having to write down and expand 4 root y times y times y times y times y and so on. So I'd rather make it into a fraction so that I can simplify it that way instead. So I get here absolute value of x over y to the power of 2. And that would be my final answer. So again, just make sure that whenever you have a case where your index is even and your exponent is even and they're both the same, you have to make sure that you show the absolute value signs all the time. Okay, let's move on to the last ones. So, writing variable expressions in simplest form. So let's start off with the first one. Again, the biggest hint that I can give here is that no matter what, and I'll write it here, always simplify your radicals. You always want to simplify your radicals before doing anything else. Whether it's combining things or like dividing or canceling them out, always simplify them out first before you do anything or solve it. That'll be like the most helpful thing to do before starting any type of problem. So now that we're done with that one, let's try out this problem over here. So again, before I do anything with trying to simplify the fraction, always start off first with seeing if you can simplify your radical side. We have 3 root y to the power of 8, so I can take out a few 3's from here. So I'm going to change this first into being x and changing my radical into an exponent. So we get here 8 over 3. And then from 8 over 3, could divide 8 over 3, which would be, I could take out 2 3's, and that would give me the remainder of 2. So this would turn into being, on the outside, I could take out, oops, I made this too big. I could take out 2 3's, but my remainder on the inside would still have to be 2. And again, please don't forget your root on the outside. On the top, I still have my x. And from there, there's nothing else I could do to cancel out the top and the bottom. But I'm not done simplifying. And the reason behind that is, again, whenever you have a radical on the bottom, you always have to get rid of it to fully simplify your answer. So you can never have a radical on the bottom of your fraction. all radicals need to disappear. So all radicals need to disappear from the bottom, no matter what. Okay, so that's what I'm going to do. I'm going to have to get rid of my radical on the bottom. So we have here x, y to the power of 2, and then we have our cubic root of y to the power of 2, right? And I'll move this lower so that's not in our way. So if my goal is to just get rid of this cubic root of y to the power of 2, then what I need to do is I can just multiply the bottom, and whatever I multiply to the bottom, I have to multiply to the top. I need to multiply this with something that would make sure that my inside of my radical is able to leave my cubic root. And so if I need to get this y to the power 2 taken out, then I need to have a group of 3 y's. But right now we only have a group of 2 y's. So if I were to multiply just one more y, so if I were to multiply cubic root y to both the bottom and to the top here, then that would change my answer, where on the bottom I would have y to the power 2, and now I would have 3, and y to the power 2 times y would give me y to the power 3 on the top. And on the top right here we would still have x cubic root of y. And so that would get rid of my cubic root, and I would be left with x cubic root of y on the top, and on the bottom I would be left with y to the power of 2 times y. And then I can combine those two together. So I would get left with x cubic root of y over y to the power of 3. That would be my final answer. Cool. Alright, last problem. Last problem on this side here, we have a big one. 14x times y to the power of 1 over 3 and 2x to the power of 3 over 4 and z to the power of negative 6. So before I do anything, I'm going to deal with my negative exponent first. And all I'm going to do is make sure that my negative exponent turns positive. And I could do that by moving it to the top of our fraction. And that would change our exponent from negative to positive. So I will have here 14x times y to the power of 1 over 3 times z to the power positive 6. And on the bottom, I still have my 2x to the power 3 over 4, right? So from here, I could see what I can combine together. I could combine my 14 over 2. So I'll do that first. 14 divided by 2, that gives me 7 times x times y to the power of 1 over 3 and z to the power 6. On the bottom, I still have x to the power 3 over 4. And I could also combine my x and my x 3 over 4. We know that whenever two of them are dividing with each other, then the exponents, and the exponent here is like an imaginary 1, the exponents are going to have to subtract with each other. So I'll rewrite this again. I'll bring up the x to the power 3 over 4 and write down x to the power of 1 minus 3 over 4. And this is multiplying with y to the power of 1 over 3 times z to the power 6. And then that would just equal to 1 minus 3 over 4. 1 minus 3 over 4. That's like saying you have 4 over 4 minus 3 over 4. And that equals to 1 over 4. So we get x to the power of 1 over 4 times y over 1 over 4 times z to the power 6. And that would be my final answer. Okay, so for 5 root 4, a to the power of 8, b to the power of 14, and c to the power of 5, first thing that I want to do is just to separate everything. It might make it a little bit easier. So we have here 5 root 4. We also have here 5 root a to the power of 8. We also have 5 root b to the power of 14. And we also have 5 root b to the power of 5. Oops, b to the power of, or c, 5 root c to the power of 5. So from here, I can't really do anything with 5 root 4. The reason being is because 4 can only go into 2 times 2. And we're grouping it by 5, so there's nothing I could do here. So I'll just leave that alone for now. But with 5 root a to the power of 8 and b to the power of 14 and c to the power of 5, there are a few things I can take out. So before I do anything, let's start off with this one first. Based off of our rule over here, where if your ends are odd and they're the same index as your exponent, then we know that this should equal to whatever your x value is. And in this case, my x value is c. So automatically I know this is going to just equal to c. So I'll leave that down here. For the other two, we can't do that because they don't have the same exponent as index, or sorry, they don't have the same index as your exponent. And so because of that, I have to figure out something else. And what I like to do is I like to change it back into the exponential form. So this turns into 8 over 5. The b value turns into being 14 over 5. And the reason why I like to do that is because of the fact that I can use division to help me identify what's going to go on the inside of my radical and what's going to go on the outside. So I have my radical sign here. I'll put my 5 here. And if I were to divide 5 divided by 8, and I'll write it actually right here. So, sorry, not 5 divided by 8, but 8 divided by 5. We could get 1 5 out of here, and I would get the remainder of 3. So whatever my remainder is going to stay in the inside of my radical. So I get here 8 to the power of 3. And on the outside is going to be what I took out. So I took out 1a so far. For b, let's see, 14 divided by 5, I can get 2 5s out from 14. That would give me a remainder of 4. So again, inside my radical sign, I can keep a b to the power of 4, so my remainder is 4. And what can be on the outside, I grouped out 2 b's, right? So the 2 comes from, goes on the outside, remainder stays on the inside. And so from here, and I'll just erase this for now, I can start rearranging things. So now I'm left with my 5 root 4 from all the way up here. I have my a value. I have my 5 root a to the power 3, b to the power 2, and 5 root b to the power 4. Now the nice thing about this is all of these variables are multiplying with each other. So because they're just multiplying, I could rearrange them to make it look combined, so I can combine some things. So I'll move the a and my b to the power 2 on the outside, and I almost forgot the c from over here, so I have to also drop down that c. And I can bring down the c over here, and all the 5 root material can go on the right here. So right here we have our 5 roots all over here on the right side instead. Okay, and I'll move it a little bit to the side. And once I do that, now I can combine all of my 5 roots together. So that's what I'll do. So over here I will combine the 5 roots. And when I combine all the 5 roots, I get 4 times a to the power 3 times b to the power 4. Drop down the a times b squared times c. And that would be my final answer.